Well, hello everybody. Dave here today to start our second lesson in a series of lessons on set theory. Today we're going to take a look at Venn diagrams a little more specifically and see how, given certain information from a problem, we are able to properly represent them using a Venn diagram. So on the front screen here you can see a classic example of a Venn diagram. In this case there's no values listed, but given some specific information about this given scenario, we should be able to do so. So let's take a look at a question like this. And we'll say in an Alberta school, there are 65 grade 12 students. That means that the rectangle, which is always meant to represent the universal set, is representing this full 65 students. And then of these students, 23 play volleyball, 26 play basketball, and there are 31 who do not play either sport. So we're going to have to start understanding the area associated with Venn diagrams and what they represent. The blue circle here represents volleyball, and based upon this question, that blue circle needs to represent the 23 players. The red circle represents the folks that play basketball. Now you'll see that these two particular circles overlap, and what that overlap represents are the number of players that play both volleyball and basketball. Well, that means that the area inside of any of these circles actually represents the number of players that play volleyball or basketball, because now you have three cases to consider. The folks that play only volleyball, the folks that play both volleyball and basketball, and the folks that play basketball only. If the area inside the circles represents the number of players that play volleyball or basketball, that means that the remaining area outside of the circles represents the number of players that don't play either of these sports. All the numbers added up need to add up to this original universal set of 65. So let's try to associate these values with the Venn diagram now. You see here that the two circles represent the sets. The rectangle on the outside represents the universal set, that everything inside has to add up to this number that we were told, which was there were 65 grade 12 students. The other piece of information that we can label directly is the number of students that don't play either of these sports, and that's 31. Now, this is where you have to do some arithmetic. If we know that there's 65 total students in grade 12 and 31 of them don't play a sport, that means 65 minus 31, which equals 34. These folks play either volleyball or basketball. So we would say that volleyball or basketball is equal to 34. Another way that you can do this with notation is actually V, this U, and B. That is the set notation for union, or in English terms, it just means or. And we know that this is equal to 34, and that's the number of people that play either or. So there's a problem. You can see that with the number that we have 23 that play volleyball and 26 that play basketball. Well, if we do 23 plus 26, we end up with 49 students. Now, that doesn't make sense because we're understanding that only 34 students play volleyball or basketball. Well, where is this number coming from? Well, in this case now we're essentially double counting, because we are double counting the number of students that play volleyball and basketball. And so if we take this sum that we have of 49 and we subtract the number that play volleyball or basketball, which is 34, we get the number 15. And the number of 15 now is actually the number of students that play volleyball and basketball. So we can write this out as the number that play volleyball and basketball. You'll see that we have this upside down U. This is the set notation for intersection, or in English terms, and. And we know that that number is equal to 15. And so if we take a look at the areas on the Venn diagram, the and is going to be the overlap of the two circles. And so that means this number right here has to be 15. Okay, now we're getting somewhere, because we were given the information about the number of people that play volleyball and the number of people that play basketball. So if we want to find just the blue area, which represents only volleyball, well, that's going to be the total number of people that play volleyball, subtract the number of people that play both, and you get an answer of 8. So there are 8 students that only play volleyball, but don't play volleyball and basketball. If we do the other one, we can see that there are 26 people that play basketball. We don't want to include the number of people that play both volleyball and basketball because we want to know the number of people that play basketball only. And we get an answer of 11. And so this is the number of people that just play basketball. They don't play volleyball and basketball. They play just basketball. Now, something cool happens here. If you take a look and we add up all our values, if we take 31 plus 8 plus 15 plus 11, we have now added up all the numbers in those respective areas for this entire rectangle. You should have gotten 65, which is the universal set. So this is how you know that you've set up a Venn diagram correctly, is if all of these values add up to what the total number of students or whatever your universal set number should be. So now we can fill out our answers to the questions below. How many students play volleyball only? Well, again, that's just the blue area, not the overlap, and so we have an answer of 8. The number of people that play both volleyball and basketball, remember, that means our intersection point, that's going to be an answer of 15. The number of people that play basketball only, we're just looking at the red area there. That gives you a number of 11. And the number of people that play neither sport, this was the answer that was already given in the problem, and it was the answer of 31. And so this is what makes Venn diagrams tricky, is the initial setup given the information you have. I like these because they're nice little math puzzles wherein you have to try and understand what information did they actually give you. The most common mistake to make is the idea that with the number saying 23 play volleyball and 26 play basketball, they actually fill those out for the only cases where there's no overlap involved. You have to recognize the fact that just because they give you those numbers, that doesn't mean that they've taken into account the folks that play both. So you have to start playing around with this math. But as far as showing work's concerned, I've shown you different ways of doing it. Certainly using set notation is going to be something you're going to want to use because down the road you're going to have equations that we're going to be able to plug these in for. But the important part here is to understand that the overlap changed the problem a little bit. So let's move to a more challenging problem. And in this case, we're going to deal with 3 sets instead of 2. The hint I'll give you right away is we will inevitably look at things as if there was only 2 sets to understand what the full 3-set scenario looks like. We know that there is a sports club where every single member has to play one of 3 sports, and then they give you a listing of information known. It's important that when you read this information, you recognize the fact that they are giving you the words and, or, and then play all 3. These are important pieces of information because remember that if we're talking about and, we mean the overlap. If we're talking about or, we mean the full area inside both circles, including the overlap. And in the case of all 3 play, that represents the center overlap of all 3 circles. You'll know that a question is more challenging when they don't give you that value because it becomes a little more algebraic to actually find that value if it's not given. So the first thing we need to do if we're going to display this information in a Venn diagram is represent each circle for a set. So in this case, we're going to call the first circle tennis, the second circle rugby, and the third circle soccer. Now, if we were using full set notation, you will want to do let statements where let t equal the set of players that play tennis, etc., etc. But in this case, we're just exploring how to set up these Venn diagrams, so I'm not too worried about notation at this point. Now we can fill in numbers that we have. We know that 4 people play all 3 sports. So I'm going to put the value of 4 right in the middle. Okay? Now we can start to play with some other ones. 11 people play tennis and rugby. Well, if you remember from the previous question, the and was the overlap of the 2 circles. And in this case, if we look at the overlap of just tennis and rugby, you can see that that also includes the number of people that play all 3. So if we know that 11 play tennis and rugby, but we know that this is also including the number of people that play all 3, then out of that 11, only 7 play tennis and rugby, but not soccer. And so you can see that understanding the overlap is essential because we know that the number inside that eye shape is 11, but of that 11, only 7 play the 2 sports, but not the 3. And so we have that information figured out. We can put a check there. 7 people play tennis and soccer. So we're going to do the exact same thing. If we know that 7 people play tennis and soccer, which is this overlap right here, and there's 4 that play all 3, we don't want to include the folks that play rugby. So in that case, it has to be 3. And so the third one, where 6 people play soccer and rugby, I think you're getting the pattern now. We take a look at the overlap of those 2 sets. If 4 people play all 3, but 6 people play soccer and rugby, we want the people to play soccer and rugby, but not tennis. That's going to be 6 minus 4, which is equal to 2. So filling out those middle numbers are by far the most important thing to do early on. And so we're done that one. Now we have to understand what we do next. Well, we know that 43 members play tennis. And you can see that in the circle for tennis, which is this big circle right here, that circle has to have 43 members inside. Well, we've already accounted for 7, 4, and 3, which is 14. So now what we can do is we can take 43 minus those 14 people, and what we will get is 29. And so 29 people play tennis only. It excludes the other cases where they play a second sport. Well, this is nice because look at the next piece of information that we can play with now. We have the idea of 84 people playing rugby or tennis. So remember that if we're talking about rugby or tennis, we mean that all the numbers inside the circles have to add up to 84. And so what do we have? Well, we know that there are 84 people total, but we need to subtract from that now the 43 people that play tennis. We also need to subtract from that the 2 people that play rugby and soccer. And what we end up with is the answer of 39. So how do you know you've done this right? Because if you take 39 plus 43 plus 2, you should end up with the answer of 84 people that play rugby or tennis. And so the ors, you can see, are a little more challenging because you have to have those middle numbers already figured out. And so the same situation comes into playing soccer or rugby. We focus on the 2 circles for rugby or soccer. We understand that the total value should add up to 68. And so the number of people that just play soccer would be 68 minus this 39 people that play rugby only. Subtract the 7 and 4 and 2. So that number is 13. And we end up with an answer of 13 people. So there are 13 people that only play soccer. So we know that there's no members outside of the circles because it tells you that each member of the sport plays at least one sport. So there is no scenario where there are anybody playing outside. If you really want to label it as a 0 so that you remember that, that's just fine. And so now it comes down to coming up with how many members does the club have? Well, because every member plays a sport, all we have to do is add up all the numbers inside. So the total is equal to your 29 plus your 7 plus your 4 plus your 3 plus your 2 plus your 39 plus your 13, and that's going to give you an answer of 97 members. So you are more than welcome to exploit the fact that we knew that the full circle of tennis was 43 or whatever scenario you want to do, but at the end of the day, every single number inside those circles has to add up to the total number of members. And in this case, we have 97. So you can see how there's pattern recognition involved, understanding what the language of the question is stating and how that relates to the Venn diagram itself. So let's take a look at one more problem just like that. In this case, we have a high school where there's 130 grade 11 students. We know that that rectangle has to represent all 130 students. There is no statement yet that every student must take one of these courses, which means that there is going to be a number outside of the circles that we have to figure out. And then they give you a bunch of information, and again, we want to make sure that we recognize the and word is really important. The or word is also important, and the idea that 11 students are taking all 3 courses is the middle overlap. Now again, focusing on these allows us to understand the order in which we should probably do the solving. If you remember from the last question, we figured out the and statements first, and then we moved to the or because we had the middle value. I would like to do that again. So we know that there are 11 students taking all 3 courses. Let's represent these sets. We'll call the first circle math, the second circle physics, and the third circle chemistry. We know that the total should be 130, so we'll address that later. We know that the middle has 11 students. Perfect. Now we can look at the 27 that take math and physics. Again, that's the overlap right here. And if 27 students are taking math and physics, that includes the 11 that take all 3. We want just the math and physics only, so we subtract 11 from 27 and we get 16. We're going to do the same for the other 2 now. The math and chemistry is this overlap right here. We know that there are 25 students taking math and chemistry, 11 are taking all 3. We want just math and chemistry only. That's 25 minus 11, which is 14. And for the third overlap, in the case of physics and chemistry, we know that there are 20 that are taking the 2, but there's 11 that are taking all 3, and so that gives us 9 that are taking just physics and chemistry, but not math. Okay, so the and statements are done. Now we can move to the statement about just taking math. There are 82 students that take math. Remember that the full circle represents these 82 students, which means that if we want to find the number that take math only, we have our 82, and we're going to subtract from it the remainder that we have here. So 16 and 11 is 27, and we could subtract that other 14, and that's going to give us an answer of 41 students. So there, again, we have the 82 students taking math, which is the full circle of math. We've already filled out our values for the ands, including the middle that are taking all 3. And so from that, we know that that full math circle adds up to 82. Well, now that we've dealt with that piece of information, we can deal with the ors. So we know that there are 110 students taking math or chemistry. So that's dealing now with the full area of the 2 circles involving math and chemistry. We only have one number that we don't have, and that's the chemistry only scenario. And so what do? Well, we know that there's 110 students that take math or chemistry, and now we're going to subtract all the rest. Well, we know that there were 82 students that took math, and that includes the overlaps and whatnot, but it didn't include that 9 additional students that took physics and chemistry only. But when we do this subtraction, what we end up with is 19. And so again, if we take 19 plus 9 plus 11 plus 14 plus 16 plus 41, that had better add up to 110, or we've made a mathematical error. And so the only piece of information we haven't used yet is that 87 students that take chemistry or physics. So now we're focusing on the area of the 2 circles that represent physics and chemistry. We've already filled out the other numbers, so now we can take the 87 students that take either or, and we can start to subtract the rest. We have a 16. We have 11 and 9, which is 20. We have that 14, and we have that 19. And that, when we do all of that subtraction, what we're going to end up with is 18. And so 18 students take physics only. Okay, so now we have all the values in the circles figured out. So we can answer B now, which is how many students are taking math or physics. To find this out, we just have to add up all the values that are inside the 2 circles for math and physics. So we have 41 plus 16 plus 11 plus 14 plus 9 plus 18. And what we end up with are 109 students. So again, the nice part about setting up your Venn diagram early is it allows you to solve all of these questions after the fact. So the last one asks us now, how many students are taking none of these courses? Well, there was still one piece of information that we didn't use, which is the fact that there is 130 grade 11 students. We now know how many students are taking at least one of the courses. So what we can do is we can take the 130 and we could subtract all of these values that we figured out inside the circle. So if we do this, what we end up with is the answer of 2. And so what that means is outside of the circles, but inside the square, we have to label that value of 2 because that's the number of students that didn't take any of these science courses. And so everybody, we have done a couple of great examples to understand how we take scenarios and information given to actually filling out a Venn diagram properly so that you can then go and use it to solve questions simply. So get to those practice problems, everybody, and we will see you again.